Alright, this is exercise video number 22, and for my exercise today I did a little bit of abs, arms, and then cardio. So I just did some crunches and then Russian twist and then just a little bit of Pilates, and then I stretched and then did bicep curls, tricep push downs, and bench press. And then I ran a mile outside with a pace of 8 minutes and 15 seconds, and after that I also stretched. And so whenever I first picked up that work rate and I started exercising, whenever I was doing abs in the beginning, or even whenever I picked up running whenever I went outside, more blood had to be delivered to my tissues in order to allow for those energy systems to occur, because we transfer oxygen through our blood. Whenever we inhale oxygen, we transfer that through our blood to our tissues, and that oxygen is used in that third pump in the electron transport chain, as we know, in order to keep all of the energy systems going. And so to get more blood delivered to my tissues, you have the accelerator nerve, which is touching the sinoatrial node in your heart. And so whenever you pick up work rate and say you need more blood delivered to your tissues, and so your heart rate needs to be above 100 beats per minute, your sympathetic nervous system will take over and it will send a signal to that accelerator nerve, and then that accelerator nerve releases norepinephrine, and then norepinephrine binds to the sinoatrial node, goes through the synaptic cleft and does that whole thing, and it increases excitatory postsynaptic potentials, which is just causing depolarization or contraction. And so whenever that hits the sinoatrial node and it gets that signal, the sinoatrial node will depolarize spontaneously more. And so the sinoatrial node already spontaneously depolarizes, but by sending that signal, you're causing that to occur more often. And so you're getting more depolarizations, more contraction, and more blood delivered to your tissues because of that contraction. And so whenever the sinoatrial node depolarizes, that signal goes throughout the both atria, and then eventually hits the atrioventricular node. And then the atrioventricular node causes a little bit delay in order for passive flow of blood into the ventricles, which is known as diastole. And then, as we know, the other 30% of blood enters the ventricles through contraction of both atria. And then once that contracts, blood fills through systole into the ventricles, and then the atrioventricular node sends its signals to bundle of Hims, and then that goes to bundle branches, and then the Purkinje fibers, and the Purkinje fibers branch up throughout the walls of both ventricles, and those cause both ventricles to contract. And then that sends blood through your aortic valve if it's coming from the left ventricle, or to the pulmonary artery if it's coming from the right ventricle. And so the reason why all of that happens more often when we're exercising is because of that accelerator nerve sending out norepinephrine and increasing excitatory postsynaptic potentials, which ultimately causes contraction and causes more blood to flow out to your tissues.